Welcome everyone. We are discussing continuity. So today I will discuss some problems of JEE Main and Wbjee. So look at the problems. Problems are all Wbjee and JEE Main. So look, problem number 1. Very simple problem of Wbjee. Fx equals to x sin 1 by x, x not equals to 0, equals to k, x equals to 0. Fx is continuous at x equals to 0, find k. So, to solve it, we know this result. Try to recall, we have already discussed it. Number 1, limit x tends to 0, x sin 1 by x equals to 0. Number 2, limit x tends to 0, x cos 1 by x equals to 0. Number 3, limit x tends to 0, sin 1 by x does not exist. And number 4, limit x tends to 0, cos 1 by x does not exist. So, you recall this result. So, not only x, if this is x square, suppose x to the power n sin 1 by x, fx equals to, for n greater than equals to 1, it is continuous. So, x sin 1 by x, this one is 0. If it is x square sin 1 by x, then it is also 0, and sin 1 by x does not exist. You know the proof, I have already discussed. Sin 1 by x lies between minus 1 to plus 1. It does not tends to any finite value. That is why sin 1 by x does not exist. Similarly, for cos 1 by x. X sin 1 by x, this is finite value, sin 1 by x, lies between minus 1 to plus 1. So, finite value, but not fixed value, but it is multiplied by 0. That is why it is 0. So, look, problem number 1. So, it is continuous at x equals to 0. So, f0 equals to limit x tends to 0, fx. So, x not equals to 0, so fx is x sin 1 by x. So, what is f0? K, and the value of the limit is 0. So, you can write it directly. Now, problem number 3. So, fx equals to x plus mod x minus 1 is continuous or not at x equals to 0 and 1. So, we know, try to recall, mod x is continuous for all x but not differentiable at x equals to 0. So, this is mod x. So, I have already discussed it. This is mod x. This is x, fx equals to, and this is minus x. Look, it has surface at x equals to 0, so it is not differentiable. We also know sum of two continuous function is continuous. Sum of finite number of continuous function is continuous. So, look, mod x is continuous for all x, and this one is also, mod x minus 1 is also continuous at x equals to 1. So, it is continuous, and sum of two continuous functions, fx equals to mod x plus mod x minus 1. So, from a well-known theorem, sum of two continuous function is continuous. So fx equals to x plus mod x minus 1 is continuous for all x. So fx is continuous at x equals to 0 and 1, it is true. Continuous at x equals to 0 but not at x equals to 1, this is not true because it is continuous at x equals to 1 also. Continuous at x equals to 1 but not so this is also not true because it is continuous at x equals to 0. And you remember it that fx equals to mod x minus 1, this is not differentiable at x equals to 0 and x equals to 1. So mod x plus mod x minus 1, this is continuous for all values of x but not continuous at x equals to 0 and x equals to 1. Although it is not given, but it is a well-known problem for differentiation. Next, these are very simple problem for Wbjee. Now, problem number 2. If R to R, real number to real number, is a function such that fx equals to this, x not equals to 0, a at x equals to 0. Find value of a for which fx is continuous at x equals to a. So, I have already solved this type of problem in part 4. So, it is continuous at x equals to 0. So, we can write f0 equals to limit x tends to 0 fx. So, limit x tends to 0 2 sin x minus sin 2x by 2x cos x. So, what is f0? f0 equals to a. Now, look, x equals to 0. So, this is 0, this is 0. 0 by 0 form. So, you can use L'Hospital rule. But look, it is product of two functions. So, that is why we are applying formula. So, sin 2x, 2 sin x cos x. And this is 2x cos x. Now, this one, limit x tends to 0, 2 sin x common, 2 sin x common, 1 minus cos x by 2x cos x. So, 2 outside, limit x tends to 0, sin by cos is tan x by x. So, this is well known, limit tan x by x. So, limit x tends to 0, 2 outside, tan x by x into limit x tends to 0, 1 minus cos x by 2. Sorry, 2 to cancel. Sorry, 2 to cancel. So, no need of writing this. 1 minus cos x. 1 minus cos x. So, sin x by cos x, tan x by x. So, this is 1. And as x tends to 0, cos x tends to 1. So, 1 minus 1 is 0. So, final result is 0. So, what is value of a? So, a is 0. So, these are all simple problems of Wbjee. Now, we can consider 3 problems of Wbjee. So, look, fx equals to log 1 plus ex minus log 1 minus x. Obviously, base is e. By x, x not equals to 0. Fx is continuous at x equals to 0, find f0. So, fifth one, fx is this, continuous at x equals to 0, find f0. So they are of same type. So consider 2. So look, f0 equals to limit x tends to 0 fx. So limit x tends to 0 log 1 plus x square tan x by sin x cube. Now this reduces to the problem of limit. So put x equals to 0, this is log 1, 0 by 0 form. So we can use L'Hospital rule. But look here, argument is this one. So you have to again use product rule. So that is why we try to use standard result of limit. What is the standard result of limit? Log 1 plus x by x, limit x tends to 0 equals to 1, and sin x by x equals to 1. So look, we can write it as limit x tends to 0 log 1 plus x square tan x by x square tan x. As x tends to 0, x square tan x tends to 0 into limit x tends to 0, x square tan x by sin x cube. Now meaning remaining same. So log 1 plus x by x, x tends to 0, so it is 1. So obviously this one is 1. And this is limit x tends to 0, tan x by x into limit x tends to 0, x cube by sin x cube. So look, x cube by x, x square, tan x by x. So finally what we are getting, this is 1, this is 1, this is 1. So what is f0? f0 is 1. So this to be noted. So if it is 0 by 0 form, we do not use L'Hospital rule always. Here, if we use standard results, then it will be simple. Next one. So you complete problem number 4. So argument is linear, so you use L'Hospital rule and try to complete. Now problem number 6. His continuity in an interval. It is continuous throughout the interval, find A and B. So two unknowns. Now condition is imposed on x equals to minus pi by 2 and x equals to pi by 2. So we use definition of continuity at x equals to pi by 2 and minus pi by 2. So right, since fx is continuous at x equals to pi by 2, limit x tends to pi by 2 plus fx equals to limit x tends to pi by 2 minus fx. And you can write also f pi by 2. But this condition is sufficient because it is continuous. Now it reduces to the problem of limit. X tends to pi by 2 plus. So this is pi by 2 plus, greater than pi by 2. So fx is cos x. Limit x tends to pi by 2 minus, it is a sin x plus b. So cos pi by 2, this is 0. This is a into 1 plus b. So we are getting one equation, that is a plus b equals to 0. Sin pi by 2 is 1. So one condition is a plus b equals to 0. So we are getting this one. So a plus b equals to 0. One equation. So call it 1. Now similarly, we use since fx is continuous at x equals to minus pi by 2, therefore limit extends to minus pi by 2 plus fx minus pi by 2 plus fx minus pi by 2 minus fx. So use definition of continuity at x equals to minus pi by 2. So this implies limit extends to minus pi by 2 plus greater than minus pi by 2. This is less than minus pi by 2, this is greater than. So a sin x plus b, limit extends to minus pi by 2 minus less than minus pi by 2. So minus 2 sin x. So a sin minus pi by 2 plus b, 2 sin minus pi by 2. You know, if it is minus pi by 2 plus minus pi by 2 minus, we always use minus pi by 2. So sine of minus theta, so minus a plus b, and this is minus, and this minus is plus 2. So minus a plus b equals to 2. And this one is a plus b equals to 0. So 2b equals to 2, so b equals to 1. So b equals to 1. So a plus b equals to 0, a equals to minus b equals to minus 1. So a equals to minus 1, b equals to plus 1. So value of a and b. So very simple. Now we consider two problems. They are problems of JEE Main. So problem number 8, the value of f0, so that fx is continuous everywhere. So you have to find f0. So it is continuous everywhere. So it is also continuous at x equals to 0. So since fx is continuous everywhere, f0 equals to limit extends to 0 fx. So limit extends to 0 fx. So this is x to the power 4, 1 minus cos, 1 minus cos x. Now cos 0 is 1. So 1 minus 1 is 0, cos 0, 1 minus 1, 0 by 0 form. But look, since denominator is x to the power 4, if you use L'Hospital rule, so you have to perform it up to 4 times. So that is why we avoid it at the beginning. So write f0 equals to limit extends to 0, 1 minus cos x, 2 sin square 1 minus cos x by 2. 2 sin square 1 minus cos x by 2 by x to the power 4. 2 sin square x by 2, 1 minus x. So if you simplify it, limit extends to 0, 2 sin square 1 minus cos x. So 2 sin square x by 2. So this is sin square x by 2. 2 sin square x by 2 by 2. So 2 cancel this 2 and this 2. So this is x to the power 4. Now 2 outside. Limit extends to 0. So sine of sin x by 2. So as x tends to 0, sin x by 2 also tends to 0. So this whole square. So sine square so this is sine square, this is sine square. So sine square, so 2 outside, sine square x by 2, this is valence. Now this one is extra. So this is sine square x by 2 whole square by x to the power 4 limit x tends to 0. Now first limit is 1. You look, first limit is 1. Sin z by z, if we consider this as z by z, so this is 1, first limit. And 2 outside, so 2 into 1. And we calculate value of this limit again. Limit x tends to 0. This is sin to the power 4. So sin x by 2 by x by 2 whole to the power 4. So sin to the power 4 is balance. And x to the power 4, this is balance. Now it is at the numerator 2 to the power 4. So 1 by 2 to the power 4. So sin square to the power 2. So sin to the power 4. Sin to the power 4 x by 2 is balance. X to the power 4, this is balance. Now it is at the numerator. So 1 by 2 to the power 4. So what is the value? 2 into 1 into 1 by 8. 2 to the power 4, this is 16. So finally it is 1 by 8. Answer is 1 by 8. So I am repeatedly saying, do not use L'Hospital rule for this type of function. So this is problem number 8. Then problem number 7. Now, fx is continuous at x equals to pi by 2. So, a pi by 2 equals to limit x tends to pi by 2 fx. So, what is fx? 1 minus sin x by pi minus 2x whole square. This is log sin x by log 1 plus pi minus 2x whole square. Log pi square minus 4πx plus 4x square. Now limit tends to pi by 2. So put a transformation. So pi by 2 minus x equals to z. Put. So pi minus 2x equals to 2z. As x tends to pi by 2, z tends to 0. So this is limit z tends to 0. So pi minus 2x is 2z. 2z whole square. 1 minus sine. What is x? Pi by 2 minus z. This is whole square. Limit z tends to 0. Log sine pi by 2 minus z. Log 1 plus pi minus 2x is z. Z square. Now next step is limit z tends to 0. 1 minus cos z by 4z square. This is limit z tends to 0. Log cos z by log 1 plus z square. So this is up to this. Now we know 1 minus cos x by x square. Limit x tends to 0. So this is half. Do not prove it. So it is problem of competition. So you write 1 by 4 into half. Now if you put z equals to 0, cos 0, so this is 1, log 1 is 0, so this is also 0 by 0 form. So if we use L'Hospital rule, This is 1 by 1 plus z square into 2z. Derivative of log 1 plus z square. And this is 1 by cos x into minus sin z. So finally what we are getting, you look, finally 8 pi by 2 equals to 1 by 8 into limit z tends to 0. So minus tan z by two z into, at the numerator it is 1 plus z square. So 1 by 8 into minus half, tan z by z is 1, and at z tends to 0 this is 1. So this is, what is the value? Value is 1 by 16. So let us verify. Let us verify. This is whole square, so 4z square. So answer is this is 1 minus cos z half, this is 1 by 8. 1 by 8 log cos z, this 2z at the denominator. So 2z. So 2z, so this is minus tan z by z into minus half. So answer will be minus 1 by 16. Minus 1 by 16. These are problems of competition, so no need of sequential steps. Now we consider true problems of J-in. So they are of same type using greatest integer function. So you know greatest integer function, third bracket x. Third bracket x. Third bracket x, and it is continuous at non-integral values but not continuous at integral values. Greatest integer function not exceeding x. Now look at the interval. The interval is 1, 2. Value of x lies between 1 and 2. So it is not continuous at integral points. So suppose third bracket x cube minus 3 equals to minus 3, minus 2, minus 1, 0 up to 8. I am repeating it again, this is not continuous at integral values. So what are the integral values? Minus 3, minus 2, minus 1, up to 8, 9 as you please. But why we are taking it up to minus 3 to minus 3 to suppose 8 or 9. So x cube minus 3, so if value is integer, then it is not, then third bracket x cube minus 3 is not continuous. So x cube minus 3 equals to, we are taking this. So what is x cube? X cube adding 3, 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9, 10, 9, 5 plus 3, 8, then 9, 10 and dot this. Now what is x? X equals to 0, 1, 2 to the power 1 by 3, 3 to the power 1 by 3, 4 to the power 1 by 3, 8 to the power 1 by 3 equals to 2, 9 to the power 1 by 3. Now look, restriction is imposed on 1 to 2. 1 is also not included. So it is not included. 2 is also not included. So 7 to the power 1 by 3. So how many values? 2 to the power 1 by 3, 3 to the power 1 by 3, 4 to the power 1 by 3, 5 to the power 1 by 3, 6 to the power 1 by 3 and 7 to the power 1 by 3. So how many? 6. It is not continuous at 6 points in between 1 and 2. So since this restriction is given, so 2 to the power 1 by 3, so 8 to the power 1 by 3 is 2. So up to this is sufficient. And 1, so no need of taking points less than 0. So we are getting how many points? 6 points. So this is interesting problem. Next one, problem number 9. We have also discussed this problem. Look, try to understand in previous class. So fx equals to third bracket x into cos. So this one, you look, you can write it as x by 2. This is pi minus pi by 2. So pi x minus pi by 2. So third bracket x cos pi by 2 minus pi x. So third bracket x. This is sin pi x. Sin pi x. It is sin pi x. Now sin pi x. So let it is simplified value. A is any real number. A is any real number. So what is fa plus? Equals to third bracket a plus sin pi a. Pi a. So third bracket a plus, this is a, and sin pi a. Sin pi a is 0 if a is integer. So this is 0. So f a minus sin pi a. So a minus is a minus 1 into 0. So equals to 0. So what is fa? Third bracket a into sin pi a. Sin pi a is 0. So fx is discontinuous at non-zero integral value. Non-zero integral value. It is not correct. Continuous only at x equals to 0. So for any value of a, if a is equal to 1, a can take any value, any integral value. A can take 1, 2, 3, 4. So at any integral value, it is continuous. So continuous only at x equals to 0. It is not true. So continuous, discontinuous at x equals to 0. This is not true. So continuous for all real x. So continuous for all real x. So option C is correct option. So today, through this video, we have discussed some problem of competitive exam. So you practice these type of problems. Find fx is given, find f0, find k. So these are very simple problems if you know limit. Thank you for today.